Have you ever wondered why the ground feels solid beneath your feet? Or why, when you press your hand against a table, it stops? It seems like the most obvious thing in the world. Things are solid. You are solid. The world is made of stuff, and that stuff takes up space, blocking other stuff from occupying that same space. It is the most fundamental experience of our lives, the sensation of touch, of resistance, of physical presence. But what if I told you that this sensation is a lie? What if I told you that the solidity you feel, the very firmness of reality that you rely on every single second of every single day, is nothing more than a ghostly trick of the light? Welcome to the quantum realm, a place where our intuition goes to die, and where the universe reveals itself to be far stranger, far emptier, and far more terrifyingly beautiful than we ever dared to imagine. Tonight, we are going to peel back the curtain of reality. We are going to descend into the microscopic abyss to uncover the 8 most brutal facts about quantum mechanics. Facts that do not just challenge our understanding of physics, but shake the very foundations of what we consider to be real. These are the truths that keep scientists up at night, staring at the ceiling, wondering if anything is actually there at all. So, find a comfortable position. Let your body sink into the bed or the chair that supports you. Feel the pressure of the surface against your skin. Close your eyes, and let us begin our descent into the void. Our journey starts right here, with that sensation of touch. Focus on your hand for a moment. Imagine we are zooming in past the wrinkles of your skin, past the fine hairs, diving down into the cellular landscape. We pass through the forest of your biology, witnessing the busy machinery of life, the cells replicating, the proteins folding, the fluids rushing like rivers. But we do not stop there. We go deeper. We shrink down past the massive DNA helices coiling like ancient serpents. We shrink until the molecules themselves, the water, the carbon chains, begin to look like vast archipelagos floating in space. And still, we go deeper. We are looking for the building blocks. We are looking for the hard, indivisible grains of sand that make up the beach of your body. We are looking for the atoms. The ancient Greeks, specifically a philosopher named Democritus, imagined atoms as tiny, solid, uncuttable spheres. For thousands of years, humanity held on to this comforting image. We believed that at the bottom of everything, there was something hard, something real, something that you could, in theory, bump into. But as we arrive at the scale of the atom, about 1/10,000,000,000th of a meter across, we find something that defies all expectation. We do not find a hard little ball. We do not find a dense fruit with a solid skin. We find emptiness. Vast, shimmering, silent emptiness. To truly understand how empty an atom is, we need to change our scale. Let us use an analogy, but let us make it grand enough to capture the true majesty of this void. Imagine a professional football stadium, a colossal bowl of concrete and steel capable of holding 100,000 screaming fans. Now, imagine that this entire stadium represents a single atom. Where is the stuff? Where is the solid part? You might think the nucleus, the heart of the atom, where the protons and neutrons live, would be a large pile of equipment in the center of the field. But no. If the atom were the size of that entire stadium, the nucleus would be a marble sitting on the 50-yard line. A single, tiny glass marble. And the electrons? The particles that we tend to think of as orbiting the nucleus, like planets orbiting a sun. They would be smaller than gnats, buzzing around the very highest seats in the nosebleed section, miles away from that tiny marble in the center. And everything else, everything between the marble and the gnats, It is empty space, nothing, void. To be precise, an atom is roughly 99.9999999999996% empty space. I want you to let that number sink in. It is not just mostly empty. It is effectively entirely empty. If you were to take every single human being on planet Earth, all 8 billion of us, and remove the empty space from inside our atoms, squashing the nuclei and electrons together so that they were actually touching, the entire human race would fit inside the volume of a single sugar cube. That is all we are, a sugar cube of matter scattered across a phantom volume of nothingness. This discovery, when it was first made in the early 20th century, was absolutely shocking to the scientific community. It was a man named Ernest Rutherford who first peered into this abyss in 1909. At the University of Manchester, Rutherford and his students were firing tiny, positively charged alpha particles at a sheet of gold foil. The foil was incredibly thin, only a few hundred atoms thick. Based on the physics of the time, they expected the alpha particles to punch right through the gold atoms like bullets through a cloud of smoke. They thought atoms were a diffuse, pudding-like paste of positive charge with electrons stuck inside like plums. But that is not what happened. Most of the particles did fly straight through, as if the gold foil was not even there. But every once in a while, one particle would hit something and bounce back. It would ricochet off the foil and strike the detector behind the source. Rutherford was flabbergasted. He later said, "It was quite the most incredible event that has ever happened to me in my life. It was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it came back and hit you. That bouncing shell proved that the mass of the atom was concentrated in a tiny, dense point, the nucleus, and the rest was just ghost town." This leads us to the most disturbing question of all, the one that makes this fact truly brutal. If the atoms that make up your hand are 99.9% empty space, and the atoms that make up the chair you're sitting on are 99.9% empty space, why don't you fall through the chair? Why doesn't your hand pass through the table like a ghost passing through a wall? If two clouds of emptiness meet, they should merge. They should not collide. So why does the world feel solid? The answer lies in the forces that rule this empty kingdom. You see, you have never actually touched anything in your life. Not once. Not your mother's face. Not the keys on your keyboard. Not the food you eat. What you perceive as touch is actually a violent interaction of fields. The electrons that orbit the nuclei of your atoms carry a negative electrical charge. The electrons in the chair also carry a negative electrical charge. And, as we know from basic magnets, charges repel each other. As your hand approaches the table, the cloud of electrons in your skin pushes against the cloud of electrons in the wood. They do not touch. They do not even get particularly close in the grand scheme of things. But the electromagnetic force is incredulously strong, billions upon billions of times stronger than gravity. So, as those electron clouds get closer, the repulsion becomes intense. It pushes back against your muscles. It sends a shockwave up your nerves. Your brain interprets this rejection, this force field pushing you away, as solidity. You are hovering. Right now, as you sit or lie there, you are hovering on a cushion of electromagnetic force, suspended nanometers above the surface of the atoms beneath you. You are levitating. The sensation of the chair is just the universe refusing to let your emptiness merge with its emptiness. We are ghosts made of energy fields, convincing ourselves that we are physical. When you look at a wall, you see a barrier, but a neutrino A tiny ghost particle that barely interacts with electromagnetic fields sees nothing. To a neutrino, the Earth is not a solid rock. It is a fog. A neutrino can travel through a light year of lead without hitting a single nucleus. To the universe at large, we are transparent. We are sparse. We are hardly there at all. This realization strips away the comfort of the material world. It forces us to accept that matter is not really what we thought it was. It is not stuff. It is localized energy. It is fields of force acting out a play of resistance. The solidity of a diamond is just a very stubborn refusal of its electrons to move. The softness of a pillow is just a more polite refusal. But in both cases, it is just empty space pushing against empty space. And this is just the first layer. This is just the lobby of the quantum hotel. Because if you think the emptiness of the atom is unsettling, wait until we look at what those particles, those tiny marbles and gnats, are actually doing inside that void. We tend to picture them as objects, don't we? Little spinning balls of charge. But as we are about to discover in the next chapter, even that is a lie. The electron is not a gnat. It is not a ball. It is something far more elusive, something that refuses to be pinned down, something that exists in a state of madness that defies all logic. We have stepped off the solid ground of classical physics, and we are now floating in the void. The safety of the real world is behind us. Ahead lies the domain of the probability wave, the collapse of reality, and the terrifying truth that the universe might not even exist when you're not looking at it. So, take a deep breath, feel the electromagnetic repulsion that you call a chair, and prepare yourself, because the emptiness we have just explored is about to get very, very weird. This is the nature of our reality, vast, hollow, and held together by the invisible tension of forces we can barely comprehend. We are not built of bricks. We are built of silence. If I asked you where you are right now, you could answer me with absolute certainty. You are sitting in a chair. You are in a room. You are at a specific address, in a specific city, on a specific continent. If we wanted to be precise, we could use GPS coordinates. We could pin your location down to the meter, the centimeter, perhaps even the millimeter. You are here, and you are definitely not there. This simple fact that an object exists in a single, defined location at a single moment in time is the bedrock of our reality. It is how we navigate the world. It is how we find our way home. It is how we know that the car driving down the street will not suddenly appear in our living room. But as we descend further into the quantum rabbit hole, we leave this comfort behind. We enter a realm where location is not a fact, but a question. And the answer to that question is never simple. Welcome to the phenomenon that shattered the nerves of the greatest physicists of the 20th century. Welcome to superposition. To understand this, we must return to our friend, the electron. In the last chapter, we saw that the atom is mostly empty space, but we still imagined the electron as a tiny speck, a gnat buzzing around the nosebleed section of a stadium. We imagined it as a thing, a tiny hard point of matter moving through space. But quantum mechanics tells us something far more disturbing. When an electron is moving through the void of an atom, it is not in any one place. It is not on the left side of the nucleus. It is not on the right side. It is not orbiting like a planet. It is everywhere at once. It is a ghost. It is a cloud of probability, a shimmering mist of potential that smears out across space. Imagine for a moment that you are like an electron. Imagine that when you leave your house to go to work, you do not walk down a single street. Instead, you dissolve. You become a wave of possibility. You flow down Main Street, but you also flow down the side streets. You are simultaneously passing the bakery, waiting at the traffic light, and walking through the park. You are in all of these places at the same exact moment. You are not a person anymore. You are a pattern of maybe. This sounds like madness. It sounds like magic. But this is not a metaphor. This is the literal description of how the building blocks of our universe behave. We know this because of an experiment that has been performed thousands of times. An experiment so simple in its setup, but so terrifying in its results, that it has been called the most beautiful and the most disturbing experiment in physics. The double slit experiment. Picture a dark room. In the center of the room, there is a barrier, a wall, with two vertical slits cut into it. Behind the barrier, there is a detector screen, a specialized canvas that lights up whenever a particle hits it. Now, imagine we have a gun, not a gun that fires bullets, but a gun that fires tiny pieces of matter, electrons. If electrons were like tiny marbles, like little solid balls of stuff, we would expect something very simple to happen. We fire the electrons at the barrier. Some would hit the wall and bounce off. Others would pass through the left slit. Others would pass through the right slit. On the detector screen at the back, we should see two bands of light, two vertical stripes directly behind the two slits. This is what common sense dictates. This is what our intuition screams must happen. But when scientists actually perform this experiment, the universe laughs at them. When they fire the electrons, they do not see two stripes. They see a pattern of many stripes. Light, dark, rippling across the entire screen. This is an interference pattern. It is exactly the kind of pattern you would get if you dropped two stones into a still pond and watched the ripples collide. Where the crest of one wave meets the crest of another, the water rises higher. Where a crest meets a trough, they cancel each other out, leaving flat water. The electrons are behaving like waves. They are rippling out from the gun, passing through both slits at the same time, interfering with themselves, and washing up on the back screen like a tide. But here is where the horror sets in. Here is the twist that keeps the scientists awake. They thought, okay, the electrons are bouncing off each other. Maybe they are crashing into each other like water molecules. So they decided to be clever. They decided to fire the electrons one by one. Click, silence. Click, silence. One single electron, traveling alone through the darkness. There is nothing for it to interfere with. There is no other electron to bounce off of. It is a solitary traveler in the void. It must choose one slit or the other. It must. But as the scientists watched, firing one electron after another, hour after hour, a chilling image began to form on the detector screen. One by one, the dots appeared, and slowly, impossibly, they built up the same interference pattern, the same ripples, the same wave. How is this possible? How can a single object traveling alone create a pattern that requires two things to interfere? The only answer, the only mathematical explanation that fits is that the single electron left the gun, dissolved into a wave of probability, passed through the left slit, passed through the right slit, passed through neither, and passed through both. It interfered with itself. It was in two places at once. It explored every possible path it could take, and only when it hit the screen did it decide to become a particle again. This implies something profound about the nature of reality. It implies that until a particle is forced to interact with something, it does not really exist, at least not in the way we think of existence. It exists as a ghost of possibilities, a phantom waiting for permission to be real. And it gets worse, because the scientists, desperate to preserve their sanity, decided to peek. They set up a measuring device, a tiny sensor right next to the slits to see which hole the electron actually went through. They wanted to catch the ghost in the act. They wanted to prove that it had to be in one place or the other. So they turned on the sensor. They fired the electron. The sensor beeped. Left slit, it said, or right slit. The ghost was caught. The electron was forced to reveal its location. But when they looked at the detector screen at the back, the interference pattern was gone, vanished, replaced by two simple clumps, two vertical stripes. The moment they looked, the electron stopped behaving like a wave and started behaving like a little marble. The moment they observed it, the magic stopped. The universe knew it was being watched. This is the observer effect, and it suggests that the act of observation is not passive. We are not just sitting in a theater watching the movie of the universe play out on the screen. We are in the movie. Our looking changes the story. By asking the question, "Where are you?" we force the electron to assume a position that it did not have before we asked. We force the nebulous, shimmering potential of the quantum world to collapse into the hard, gritty reality of the everyday. This leads us to a question that borders on the philosophical, perhaps even the spiritual. If reality only snaps into focus when it is observed, what happens when we are not looking? Does the moon continue to exist when no one is gazing at it? Albert Einstein, who was deeply troubled by these discoveries, famously asked this very question to a colleague while walking home from the Institute for Advanced Study. "Do you really believe," he asked, "that the moon is not there when you're not looking at it? It seems absurd. Of course the moon is there. It has mass. It has gravity. It has been there for billions of years. But in the strict language of quantum mechanics, until a measurement is made, we cannot speak of the moon's position with absolute certainty. We can only speak of probabilities. Now, for a giant object like the moon, those probabilities are so stacked that it might as well be solid. The wave function of the moon is extremely sharp. But for the atoms that make up the moon, for the particles that make up the light reflecting off its surface, they are dancing in the mist. They are slipping in and out of location, playing a game of cosmic hide-and-seek until a photon hits your retina and forces the universe to say, "Here, I am here." This means that reality is not a fixed stage set. It is a fluid, interactive dream. The chair you are sitting on feels solid, as we learned, because of forces. But its location, its precise configuration in space, that is being constantly updated, constantly collapsed from probability into certainty by the trillions of interactions happening every microsecond. The air molecules hitting it, the light photons bouncing off it, the pressure of your body against it. The universe is constantly measuring itself, constantly collapsing its own wave functions, weaving the tapestry of reality thread by thread, moment by moment. But what if you could isolate something? What if you could take a piece of matter and shield it from everything? Shield it from light, shield it from heat, shield it from air. Create a perfect, cold, dark void where no observation could occur. Scientists are doing this right now. They are building quantum computers. They take tiny loops of metal, cool them down to near absolute zero, cooler than the deepest void of space, and isolate them until they enter this ghostly state of superposition. In that silence, in that darkness, the metal is not on or off. It is both. It is dreaming. It is calculating all possibilities at once. It is tapping into the shadow world that underlies our own. And the power of these machines comes from the very fact that they are not quite real. They operate in the mist. They operate in the gap between here and there. So, as you sit here, reading these words, ask yourself again, where are you? You feel the weight of your body. You see the walls of your room, but deep down, in the basement of your being, in the secret heart of your atoms, you are not really anywhere. You are a swarm of ghosts. You are a collection of probabilities that have agreed, for this brief moment, to appear as a person. You are a wave that has crashed upon the shore of perception, but the ocean is still there. The vast, silent, unformed ocean of the quantum realm is washing through you right now. Every particle in your body is itching to dissolve. Every electron in your brain is waiting for the moment when no one is looking so it can spread its wings and be everywhere at once. The solidity of the world is a desperate truce, a handshake between the observer and the observed. And if that handshake were ever broken, if the observer were to blink, what would remain? Would the world dissolve back into the mist? Would the silence reclaim the shapes? We do not know. We only know that the ghost is real, and it is haunting every single atom of the universe. This concept of things not being real until they interact brings us to an even darker realization. If particles are just waves of probability, what connects them? Is it possible for two ghosts, separated by the entire width of the universe, to feel each other's pain, to dance in perfect synchronization across the infinite void? The answer is yes, and it is the third brutal fact on our list, a phenomenon so strange that Einstein called it spooky action at a distance. We are about to enter the realm where space itself becomes meaningless, where distance is an illusion, where everything, everywhere, is connected by invisible threads that ignore the speed of light and the laws of time. So, hold on to your location while you still can. Grip the arms of your chair, because we are about to sever the connection between here and there completely. We are about to discover that in the quantum world, no one is ever truly alone. Loneliness is a feeling we all know. It is the sensation that we are distinct, separate entities, cut off from the rest of the world by the barrier of our skin. You are there. I am here. Between us lies a gulf of empty space, a physical distance that must be crossed if we want to communicate or touch. If I want to send a signal to you, I have to shout or wave a hand or send a radio wave. And that signal has to travel. It has to move through the air, obeying the speed limit of the universe, the speed of light. Nothing can travel faster than light. This is the golden rule of physics, laid down by Einstein himself. It means that we are always trapped in the past of the things we see. When you look at the sun, you are seeing it as it was 8 minutes ago. When you look at a star, you are seeing it as it was 1,000 years ago. Distance means delay. Distance means separation. But the third brutal fact of quantum mechanics destroys this idea completely. It suggests that at the deepest level of reality, distance is an illusion. It suggests that separation is a lie we tell ourselves to make sense of the world. Welcome to the phenomenon that Albert Einstein called spooky action at a distance. Welcome to quantum entanglement. To understand this, we have to go back to the birth of particles. Sometimes, in the violent heart of an atom or in the beam of a laser, two particles are created together. They are born from the same burst of energy. They are twins. According to the laws of quantum mechanics, these two particles are not really two separate things. They are two halves of a single whole. They share a wave function. They are mathematically linked in a way that is impossible to break. Let us imagine these particles are electrons. And let us focus on a property called spin. Now, spin is a bit of a misnomer. The electron is not physically spinning like a top, but it has a magnetic orientation. It can be pointed up, or it can be pointed down. Because these two twins were born together, the conservation laws of the universe dictate that they must balance each other out. If one is spin up, the other must be spin down. The total spin must be zero. This seems simple enough. If I have a pair of gloves and I put the right glove in one box and the left glove in another box, I know that if I open the first box and find a right glove, the other one must be the left glove. But remember the lesson of the last chapter. Remember the nightmare of location. Until we look, the electron is not up or down. It is both. It is hovering in a state of superposition, a shimmering mix of upness and downness. And because the twins are entangled, they are both hovering. They are both undefined. Now, here is where it gets terrifying. Let us take these two entangled electrons. Let us keep one here in a laboratory on Earth. And let us take the other one and put it on a spaceship. Let us fly that spaceship to the other side of the galaxy. Let us take it to the Andromeda Galaxy, 2.5 million light-years away. So now we have two tiny specks of matter separated by a gulf of darkness so vast that light itself takes millions of years to cross it. They are alone. They are isolated, or so it seems. Back on Earth, a scientist decides to make a measurement. She decides to force the electron to choose. She sets up her detector and measures the spin. The universe snaps into focus. The wave function collapses. Spin up, the detector says. At that exact instant, not a second later, not a millisecond later, but at that exact moment of now, the electron in the Andromeda Galaxy changes. It snaps out of its superposition. It stops being a cloud of probability, and it becomes spin down. It knows what its twin did. It knows that its partner was measured, and it knows with absolute certainty that it must assume the opposite state to keep the universe in balance. How did it know? How did the information travel from Earth to Andromeda instantaneously? It didn't travel. To travel would imply crossing the space between them. To travel would take time. And this connection happens outside of time. It happens as if the 2.5 million light-years of space simply did not exist. This shattered Einstein's view of the universe. He believed in local realism. He believed that things only affect their immediate surroundings. He believed that if something happens here, it cannot affect something over there unless a signal travels between them. He argued that there must be hidden variables, secret instructions inside the particles that determine their state beforehand, like the gloves in the boxes. He thought the universe was predictable. He thought it played fair. But he was wrong. Decades of experiments, starting with the brilliant work of John Stuart Bell and proven by physicists like Alain Aspect, have shown that there are no hidden variables. The gloves are not gloves until you open the box. Before that, they are undefined potential, and the connection is real. This means that space, the thing that separates you from the wall, the thing that separates the earth from the sun, the thing that we think of as the stage of the universe, is not fundamental. Space is emergent. Space is a secondary effect. Beneath the fabric of space, there is a deeper layer of reality where everything is mashed together, where there is no here and no there. There is only one single unified object. Think about the implications of this. If two particles can be entangled, allowing them to communicate across the universe instantly, what about 3 particles? What about 1 trillion? What about the entire universe? Go back to the very beginning. Go back to the Big Bang. 14 billion years ago, all the matter and energy in the universe was compressed into a singularity. Everything that exists today, the atoms in your body, the gas in the heart of Jupiter, the rocks on Mars, the light from the most distant galaxy, it was all touching. It was all part of the same primordial fireball. It was all entangled. And if quantum mechanics holds true, that entanglement has never been fully broken. We are still connected. The atoms in your right hand are entangled with atoms in a star that died 1 billion years ago. The electrons in your brain are dancing in sync with particles drifting in the intergalactic void. We are not isolated fragments moving through a lonely cosmos. We are simply the localized ripples of a single, vast, interconnected ocean. This is the death of separation. It is a beautiful thought, but it is also a brutal one, because it means that privacy is an illusion. It means that isolation is impossible. It means that everything you do, every movement you make, every thought you have, sends a tiny tremor through the web of the universe. You cannot sever yourself from the whole. You are woven into the fabric of existence so tightly that to pull on one thread is to shake the entire tapestry. When scientists look at entangled particles, they are not seeing two things communicating. They are seeing one thing that happens to be in two places. Or rather, they are seeing one thing that has tricked us into thinking that places are real. This challenges our very concept of identity. We define ourselves by our boundaries. I end at my skin. The world begins outside of me. But in the quantum view, these boundaries are arbitrary. They are fuzzy lines drawn on a map that the territory does not recognize. The universe is a holism. It is a single, undivided event that is still unfolding. We are not the actors on the stage. We are the stage. We are the script. We are the audience. We are all of it, experiencing itself from 1 trillion different perspectives at once. This realization brings a strange kind of vertigo. It is the vertigo of infinite connection. We often feel small in the universe. We feel like tiny specks lost in the dark. But entanglement tells us that we are not lost. We are tethered. We are held. We are part of a system so intricate and so intimate that the beating of a heart on earth is felt in some subtle, ghostly way by the furthest reaches of creation. The silence of space is not empty. It is humming with the conversation of entangled ghosts. It is alive with the invisible threads that bind the many into the one. And as we sit here, contemplating this mystery, we must ask ourselves, if everything is connected, if the universe is truly one single quantum object, then what is empty space? If space is not a barrier, what is it? Is it just a container? Is it truly nothing? Or is the nothingness itself alive? Is the void actually a seething, boiling cauldron of energy that is more real than the matter it contains? This brings us to our fourth brutal fact. We are about to look into the darkness itself. We are about to stare at the empty space in front of your face and realize that it is not empty at all. It is heavy. It is violent, and it might be the only reason we exist at all. So, let go of the idea that you are alone. You never were. You never could be. You are entangled with the stars, and now we turn our eyes to the space between them, the vacuum, the abyss, the place where monsters are born from nothing. When we think of the word nothing, we tend to imagine a void. We picture a box from which everything has been removed. We take out the object. We pump out the air. We shield it from light, from radio waves, from radiation. We cool it down to absolute zero, freezing any lingering thermal vibration. In our classical intuition, what remains in that box is true emptiness. It is a stage without actors. It is a silence so profound that it lacks even the potential for sound. It is the absence of being. But the fourth brutal fact of quantum mechanics is that there is no such thing as nothing. The concept of empty space is a fiction, a relic of a time when we did not have eyes sharp enough to see the seething, boiling madness that fills the gaps between the stars. We are about to discover that the void is not passive. It is not a blank canvas. It is a violent, churning ocean of energy that is more alive, more energetic, and more terrifyingly potent than any star or galaxy. Welcome to the quantum vacuum. To understand this, we must return to the uncertainty that rules the microscopic world. We have already met the Heisenberg uncertainty principle in the context of position and momentum, the idea that you cannot know where a particle is and where it is going at the same time. But there is another version of this principle, one that relates energy and time. It states, with mathematical precision, that you cannot know the exact energy of a system for a precise duration of time. The shorter the time interval you look at, the more uncertain the energy becomes. This sounds like a technicality, a bookkeeping error in the laws of physics, but its implications are shattering. It means that for incredibly brief moments of time, fractions of a second so small that they defy human comprehension, nature is allowed to cheat. Nature is allowed to break the law of conservation of energy. It can create energy out of nothing, provided that it destroys it again quickly enough. Think of it like a loan from a cosmic bank. You can borrow a tremendous amount of money, $1 billion, as long as you pay it back within a nanosecond. If you pay it back fast enough, the bank does not notice, and the books remain balanced. In the quantum vacuum, this borrowing happens everywhere, all the time, in every cubic centimeter of space in the universe, right in front of your face, in the empty air between your eyes and this screen. Particles are popping into existence. They appear out of nowhere, born from the pure potential of the vacuum. They are always created in pairs, a particle of matter and a particle of antimatter, an electron and a positron, a quark and an antiquark. They burst into reality, borrow energy from the void, exist for a fleeting moment, and then crash back together, annihilating each other and returning their energy to the bank. These are called virtual particles. But the name is misleading. They are not virtual in the sense of being imaginary or simulated. They are virtual only in the sense that they are temporary. While they exist, they have real effects, they have real mass, they exert real forces. Imagine the surface of a pot of boiling water. Bubbles rise, burst, and disappear. The surface is never still. It is a chaotic, frothing landscape. Now imagine that the water is invisible. That is the fabric of space. It is a quantum foam, a rolling sea of creation and destruction that never sleeps, never pauses, never calms. You might be thinking, this sounds like a nice theory, but is it real? Can we prove that nothing is actually something? Yes. We can prove it with two metal plates. This is known as the Casimir effect, named after the Dutch physicist Hendrik Casimir, who predicted it in 1948. Imagine taking two perfectly flat, uncharged metal mirrors and placing them in a vacuum. You place them incredibly close together, micrometers apart. According to classical physics, there is nothing between them and nothing outside them. They should just hang there, motionless. But they don't. They are pushed together. A mysterious, invisible force crushes them toward each other. Why? Because of the boiling ocean. Outside the plates, in the vast open space, virtual particles of all sizes and wavelengths can pop into existence. big waves, small waves, medium waves. They're pushing on the outsides of the plates like a storm, battering a ship. But in the tiny gap between the plates, space is limited. Only the small waves fit. Only the tiny virtual particles can pop into existence there. The big waves are excluded. This creates an imbalance. There is more storm outside the plates than there is inside. There is more pressure from the nothingness pushing in than there is pushing out. And so the plates are crushed together by the sheer weight of empty space. The vacuum is not empty. It has pressure. It has power. It is capable of moving physical objects simply by being there. This leads us to the most brutal aspect of this fact, a realization that scares scientists not because of its complexity, but because of its magnitude. If empty space is full of energy, how much energy is there? If we could sum up all the fluctuations, all the popping particles, all the jittering fields in a single coffee cup of empty space, how much power would we have? When physicists try to calculate this using the standard model of particle physics, they get a number that is effectively infinite. But when they try to put a reasonable cap on it, assuming that space is granular at the Planck scale, they still get a number that is mind-bogglingly large. The calculation suggests that the energy contained in the empty space inside a single light bulb is enough to boil all the oceans of the world. In fact, it is enough to vaporize the entire planet. It suggests that the energy density of the vacuum is a number with more than 100 zeros. This is where the nightmare begins. Because we know that energy has mass, Einstein taught us that E equals mc squared. If empty space is that heavy, if it is that packed with energy, it should have gravity, enormous gravity, so much gravity that the universe should have curled up into a ball and collapsed into a black hole instantly after the Big Bang. The universe should not be expanding. It should be crushed by its own emptiness. But we look out at the night sky, and what do we see? We see a vast, expanding, accelerating cosmos. We see galaxies drifting apart. We see a universe that acts as if the vacuum energy is tiny, almost zero, but not quite. This discrepancy is known as the vacuum catastrophe. It is the single worst prediction in the history of physics. The theoretical calculation of how heavy nothing should be differs from the observed reality by a factor of 120 orders of magnitude. That is, a 1 followed by 120 zeros. It is an error so colossal that it suggests we are missing something fundamental about the nature of reality. It suggests that either our understanding of the quantum world is deeply flawed, or our understanding of gravity is wrong, or that there is some magical cancellation mechanism we have not yet found that tames the violent ocean of the void. But the fact remains, we are not floating in an empty room. We are submerged in a fluid of infinite power. We are like fish swimming in the deepest, darkest trench of the ocean, unaware of the immense pressure pressing against our scales, because it is balanced from the inside. Every atom in your body is interacting with this field. The electrons in your atoms are not just orbiting, they are constantly shaking hands with the virtual particles of the vacuum. They are being dressed by the void. If the vacuum were truly empty, you would not exist. At least, not in the form you do now. Your atoms would fall apart. The forces that hold you together are transmitted through this boiling soup. This changes the way we look at stillness. We seek silence. We seek peace. We close our eyes and try to empty our minds. We look at the night sky and see a placid, quiet dark. But true silence is impossible. Even in the deepest meditation, even in the coldest death, the substrate of reality is screaming with activity. The floor of existence is not a solid foundation. It is a trapdoor opening onto a furnace of creation. The ancient mystics often spoke of a plenum, a fullness that underlies the apparent emptiness of the world. They spoke of a void that was not empty, but pregnant with potential. Quantum mechanics tells us they were right. The nothing is the mother of everything. And this brings us to a chilling thought about the stability of our universe. If the vacuum is full of energy, is it stable? Is this the lowest possible energy state? Or are we standing on a false floor? Imagine a ball resting in a valley. It is stable. If you nudge it, it rolls back down. But what if that valley is actually high up on a mountain? What if there is a deeper, lower valley further down? What if the nothing we see is not the true nothing? What if the vacuum could decay? This is the concept of false vacuum. If our universe is currently resting in a false vacuum, a state that is stable for now, but not the lowest possible energy state, then it is possible that at any moment, somewhere in the universe, a tiny bubble of true vacuum could appear. A bubble where the laws of physics are different. A bubble where the energy of nothing is lower. Because nature always seeks the lowest energy state, that bubble would expand. It would expand at the speed of light. It would be a wall of destruction that would rewrite physics as it passed. Atoms would fall apart. Forces would decouple. Matter, as we know it, would cease to exist. And because it travels at the speed of light, we would never see it coming. One moment, we are here, pondering the mysteries of the quantum foam. The next moment, simple, total, instant non-existence. The ultimate return to a new kind of nothing. It is a brutal fact, but there is also a strange comfort in it. It reminds us that existence is a delicate balancing act. We are surfing on the crest of a wave that has been rolling for 14 billion years. The fact that the ocean is deep and dark and full of monsters does not mean we cannot enjoy the ride. In fact, it makes the ride all the more miraculous. We are structures of order floating on a sea of chaos. We are fleeting patterns of stability in a universe that is fundamentally unstable. And yet, we are here. The foam supports us. The vacuum breathes life into our atoms. The energy that could destroy us is the same energy that sustains us. So, the next time you feel empty, the next time you feel like you are nothing, remember the quantum vacuum. Remember that in the logic of the universe, nothing is just a word for infinite potential. Remember that even the darkest, coldest, most abandoned corner of space is overflowing with the energy of creation. You are never truly empty. You are built on a foundation of infinite fullness. But if the vacuum is boiling with temporary particles, what happens when we try to pin down the flow of time itself? If energy can be borrowed from the future to be used in the present, does time even flow in a straight line? Our fifth brutal fact takes us into the mechanism of the clockwork itself. We are going to find that in the quantum realm, the arrow of time is not an arrow at all. It is a loop. It is a blur. And sometimes effects can happen before their causes. Prepare to unlearn the past. Prepare to doubt the future, because we are about to step out of the river of time and watch it flow backward. Time is the ultimate river. We are born into its current, and from the moment we take our first breath, we feel it pulling us forward. It flows in one direction. From the past, through the fleeting needle point of the present, toward the misty, unformed ocean of the future. We remember yesterday. We experience today. We anticipate tomorrow. This sequence is the most fundamental structure of our conscious experience. It is the story of cause and effect. The glass falls. and then it shatters. The sun rises, and then the day warms up. You press a button, and then the bell rings. It is impossible, in our everyday logic, for the glass to shatter before it falls. It is impossible for the bell to ring before you decide to press the button. The past is written in stone, locked away in the archives of history, unchangeable and fixed. The future is an open book waiting to be written by the choices we make in the present. This is the arrow of time, and it flies straight and true. But, as we have learned on this journey into the quantum abyss, our intuition is often a cage that hides the true wildness of reality. Our fifth brutal fact is perhaps the most difficult to accept because it violates the very narrative of our lives. It suggests that in the quantum realm, the arrow of time is not straight, it is not rigid, it can bend, it can loop, and under certain conditions, the choices you make in the future can reach back and rewrite the past. Welcome to the mind-bending phenomenon of retrocausality and the delayed choice quantum eraser. To understand this, we must return to the behavior of light. Think of a photon, a single tiny packet of light traveling through the cosmos. We know from our previous chapters that this photon behaves like a wave. If it encounters two slits, it passes through both, creating an interference pattern. If we watch it, it behaves like a particle, choosing only one path. But the great physicist John Archibald Wheeler asked a question that haunts the corridors of physics to this day. He asked, when does the photon decide? Does it decide to be a wave or a particle at the moment it leaves the source? Does it decide at the moment it passes through the slits? Or does it decide only when it arrives at the detector? To answer this, Wheeler proposed a thought experiment that was later turned into a real laboratory experiment. Imagine we have our double slits set up again, but this time we make it much, much longer. Imagine the distance between the slits and the detector is vast, light years even. The photon flies toward the slits. It passes them. At this point, according to our logic, the event has happened. It has either gone through one slit as a particle or both as a wave. The history of that passage is now in the past. But here is the twist. Wheeler imagined a way to choose how we measure the photon after it has already passed the slits. We can decide at the very last second, just before the photon hits the back wall, whether we want to look at which path information or interference information. We make this decision long after the photon has completed the difficult part of its journey. If the past is fixed, our decision now shouldn't matter. The photon has already done what it did. It is already a wave, or already a particle. But when scientists perform this experiment, the universe defies logic again. If we decide now to look for a path, the data shows that the photon back then behaved like a particle. If we decide now to ignore the path and look for interference, the data shows that the photon back then behaved like a wave. It is as if the photon, traveling through the dark, sensed what we were going to do in the future. It is as if our choice in the present reached back through time, grabbed the photon as it was passing the slits, and told it how to behave. Wait, you might say. This is just a trick of measurement. But it gets even deeper. Let's scale this up to the cosmos, as Wheeler famously did. Imagine a distant quasar, a brilliant beacon of light, powered by a supermassive black hole, sitting billions of light years away. Between us and that quasar lies a massive galaxy. The gravity of this galaxy acts like a lens, bending the light from the quasar. This is a gravitational lens. Because of this bending, the light has two paths to reach Earth. It can go around the left side of the galaxy, or it can go around the right side. This is a cosmic version of the double slit experiment. The slits are the two sides of the galaxy. The screen is our telescope here on Earth. The photon left that quasar billions of years ago, long before the Earth was formed, long before the dinosaurs, long before you were born. It traveled through the void for eons, passing that galaxy, making its way to us. Now tonight, an astronomer points a telescope at that quasar. She has a choice. She can choose to focus the telescope to see which side of the galaxy the light came from, left or right. Or she can choose to combine the light from both sides to create an interference pattern. She makes this choice now, tonight. But the photon passed the galaxy billions of years ago. If she chooses to measure the path, the photon must have chosen one side of the galaxy way back in the deep past. If she chooses to measure the interference, the photon must have taken both paths way back in the deep past. This implies that the astronomer's choice, made in 2026, determines the history of a particle that occurred billions of years before she existed. Her observation creates the past. This is the delayed choice. It suggests that history is not a solid timeline that we leave behind. It is a cloud of ambiguity. It is a fog of what might have been that only hardens into what was when it is recorded in the present. The past exists in a state of superposition until the present observes it. This concept dissolves the bedrock of cause and effect. We tend to think that the past causes the future. The kick causes the ball to move. But in the quantum world, the relationship is symmetric. The future can inform the past just as much as the past creates the future. This is known as retrocausality. It does not mean you can send a winning lottery ticket back to your younger self. The universe protects itself from paradoxes on the macro scale. But on the micro scale, on the scale of the fundamental building blocks of reality, the distinction between before and after is blurred. Time is not a sequence. Time is a block. It is a landscape that exists all at once. And we are just crawling across it, illuminating one slice at a time with the flashlight of our consciousness. To further terrify you, let us look at the quantum eraser variation of this experiment. This setup is even more diabolical. In this version, we use entangled photons. We send one photon, the signal, to a screen to make a pattern. We send its twin, the idler, off to a complicated maze of detectors. This maze allows us to know which path the signal photon took. But we include a special device, an eraser. This device can scramble the information from the idler photon. It can erase the knowledge of which path it took. Here is the kicker. We can choose to erase that information after the signal photon has already hit the screen. We look at the screen, we see a pile of dots. It looks like a mess, no pattern. Then we look at our idler data. We sort the dots on the screen based on what happened to their twins in the future. And suddenly, the pattern emerges. The dots that correspond to the erased path information form an interference pattern, wave behavior. The dots that correspond to the known path information form a clump, particle behavior. The pattern was there all along, hidden in the mess, waiting for the future choice to unlock it. It implies that the information about the past was always fluid, always waiting for the final context to be applied. This leads to a profound philosophical vertigo. If the universe waits for an observer to determine its history, what does that say about the Big Bang? What does that say about the billions of years of cosmic evolution before life appeared? John Wheeler proposed the participatory anthropic principle. He suggested that the universe might not have really existed in a defined state until conscious observers evolved to look at it. He imagined the universe as a great loop, a U shape. At one end is the Big Bang. At the other end is us. And we, by looking back at the cosmic microwave background, by studying the ancient stars, by measuring the photons from the beginning of time, we are the ones who make it real. We are the ones who collapse the wave function of the early universe. We are creating our own origin story simply by looking for it. We are not just children of the cosmos. We are its parents. This is a heavy burden. It means that your act of witnessing the world is not passive. It is an act of creation. It is an act of historical revision. Every time you look at a star, you are participating in a quantum transaction that spans millennia. You are the anchor point for a chain of events that started long ago. Without you to catch the light's journey remains a ghost story, a probability, a maybe. With you, it becomes a fact. I was here, the photon says. I traveled this path, but only because you opened your eyes. This erodes the solidity of your own personal history. We cling to our memories. We define ourselves by what we have done, where we have been, what we have suffered. But if the quantum past is fluid, perhaps our personal past is less rigid than we think. Perhaps the narrative of your life is constantly being recontextualized by who you are today. Perhaps the person you are right now is rippling back through time, subtly shifting the emotional weight, the meaning, the very spin of your memories. You are not a victim of your past. You are in a constant dynamic dialogue with it. The you of 10 years ago and the you of today are entangled, influencing each other across the gap of time. This erasure of time brings us a strange kind of peace. We worry so much about running out of time. We worry about the sand slipping through the hourglass. We feel the pressure of the ticking clock. But if time is a construct, if the future is already there, pulling us toward it, and if the past is still here, waiting for us to define it, then the rush is an illusion. There is no race. Everything is happening in a vast, eternal now. The silence of the quantum realm is the silence of eternity. It is the stillness of a universe where everything is already complete, and yet, paradoxically, still being written. Imagine your life as a piece of music, recorded on a vinyl record. The whole song is there on the disc, the beginning, the middle, the end. They exist simultaneously. The needle is your consciousness. It rides the groove, playing the notes one by one. To the needle, the music flows. To the needle, the previous note is gone, and the next note is a mystery. But to the record, the song is a whole. And in the quantum world, the needle can jump, the needle can skip. The needle can be in two grooves at once. We are learning that the record player is much more complex than we thought. We are learning that the listener helps write the song. So, as you sit here in the quiet, listen to the silence of the room. Is it a silence of emptiness, or is it a silence of waiting? Is the future holding its breath, waiting for you to make a choice so it can decide what happened in the past? Are you the weaver of the timeline? The power of the observer is not just to see what is there. It is to decide what was there. This is the ultimate responsibility, and it is the ultimate freedom. You are not just a leaf floating on the stream of time. You are the water. You are the riverbed. You are the gravity that pulls it flow. And this brings us to the edge of the physical world. If our consciousness plays such a pivotal role in creating reality, if looking at the universe changes the universe, then we must ask the question that physicists have tried to avoid for a century. What is consciousness? Is it just a byproduct of brain chemistry? Or is it something fundamental, something that stands outside the equations? Our sixth brutal fact forces us to confront the role of the mind in the machine. We are going to explore the possibility that the universe is not made of matter, but of mind. We are going to look at the Wigner's friend paradox and the terrifying suggestion that there is no objective reality at all, only a subjective web of observations. So, let go of the clock, let go of the calendar. They are just tools for the macro world. In the deep, deep down, it is always now, and now is where the magic happens. We assume that the world is out there. We assume that if every human being, every animal, and every conscious creature were to suddenly vanish from the universe, the stars would keep burning, the planets would keep orbiting, and the atoms would keep bouncing off each other in the dark. We believe in an objective reality, a single, hard truth that exists independently of whether anyone is looking at it. The chair is red, the stone is heavy, the electron is spin up. These seem like facts. They do not seem like opinions. But the sixth brutal fact of quantum mechanics challenges this assumption in a way that is deeply unsettling. It suggests that there is no such thing as a view from nowhere. It suggests that facts are not absolute. They are relative to the observer. It suggests that you and I could look at the same event, see two contradictory things, and both be correct. Welcome to the paradox known as Wigner's friend. To understand this, we must return to the moment of collapse. We learned that when we measure a particle, its wave function, the cloud of probabilities, snaps into a single state. It goes from being up and down to just up. This seems straightforward. The measurement is the trigger. But in 1961, the Nobel Prize-winning physicist Eugene Wigner asked a simple but devastating question. What counts as a measurement? Is it the machine clicking? Is it the light hitting the retina? Or does it require a conscious mind to register the result? Wigner proposed a thought experiment to test the limits of reality. Imagine a sealed laboratory. Inside this laboratory, Wigner places a friend. Let us call him John. John has a quantum device, a simple setup with a single electron and a detector. John's job is to measure the spin of the electron. John is a competent scientist. He runs the experiment. The universe inside the lab decides. The electron collapses. John sees the result. Spin up. He records it in his notebook. To John, the measurement is done. The probability wave has vanished. Reality is fixed. But now, let us pull the camera back. Eugene Wigner is standing outside the laboratory. The door is locked. The walls are soundproof. He cannot see inside. From Wigner's perspective, standing outside, he has not yet made a measurement of the lab. According to the strict laws of quantum mechanics, specifically the Schrödinger equation, which governs how quantum systems evolve, an isolated system remains in superposition until it is interacted with from the outside. So, to Wigner, the entire laboratory is a quantum system. This means that, to Wigner, the electron has not collapsed. But it gets weirder. Because John is part of that system, John has not collapsed either. From Wigner's perspective, John is in a state of superposition. He is in a ghostly mixture of John who saw spin up and John who saw spin down. Both versions of John exist simultaneously inside the room. Both realities are playing out at once. It is only when Wigner opens the door and asks, "What did you see?" that the superposition collapses for Wigner. Only then does John become a single person with a single memory. Now, here is the nightmare. Who is right? Inside the room, John is certain that the collapse happened moments ago. He feels real. He does not feel like a ghost. He has already written the result down. But outside the room, Wigner is mathematically certain that the collapse has not happened yet. He treats John as a wave function. They have two different accounts of when reality became real, and according to quantum mechanics, both of them are correct. This implies that there is no single timeline. There is no single now where everything happens. Reality is fragmented. It is dependent on who is looking and from where. For decades, this was just a philosophical puzzle. Physicists argued over it. Some said, "Don't be silly. A person can't be in superposition. Consciousness collapses the wave automatically." Others said, "No, the math doesn't care if you are a person or a rock. If you are isolated, you are a wave." But in 2019, scientists at Heriot-Watt University in Edinburgh actually performed a version of this experiment. They didn't use a human friend. Ethics committees are strict about putting people in superposition. But they used a complex setup with entangled photons that acted as observers. They created a scenario where one photon measured another, and a second photon measured the first one. The results confirmed Wigner's fear. The two observers disagreed on the state of reality. One observer saw a fixed outcome. The other observer saw a superposition. And the experiment proved that both observations were valid simultaneously. This forces us to confront the possibility of solipsism. Solipsism is the philosophical idea that only your own mind is sure to exist. Everything else, the world, other people, the stars, might just be projections of your own consciousness. In the context of Wigner's friend, it suggests that you are trapped in your own bubble of reality. When you look at the world, you collapse your version of it. But you can never know if your version matches anyone else's. You might be the Wigner to my John, or I might be the Wigner to your John. We are walking around in private universes that only partially overlap. This dissolves the very idea of objectivity. If facts are relative to the observer, then what is the universe? Is it just a soup of subjective experiences floating in the void? Some physicists, desperate to avoid this trap, have proposed an even more radical solution. They say, okay, maybe the wave function never collapses at all. Maybe John really is in both states. Maybe when Wigner opens the door, he doesn't collapse John. He joins him. Wigner splits into two. One version of Wigner meets the John who saw spin up. Another version of Wigner meets the John who saw spin down. This line of thinking leads directly to the many worlds interpretation, the idea that every possible outcome happens in a separate branch of reality. We will explore that terror in the next chapter. But for now, stay with the horror of the consciousness trap. Think about the implications for your own life. If consciousness is the mechanism that makes reality real, then what happens when you are not conscious? When you fall into a deep, dreamless sleep, or when you go under anesthesia? Does your universe dissolve? Does the wave function of your bedroom spread out, the walls becoming mist, the bed becoming a cloud, until you wake up and force it back into shape? It sounds like a fairy tale. But we have no proof that it doesn't happen. We assume continuity. We assume the world waits for us. But assumption is not proof. This also raises the question of the ultimate observer. If John needs Wigner to collapse him, and Wigner needs Wigner's wife to collapse him, and the wife needs the mailman, where does the chain end? Who observes the universe as a whole? Is there a cosmic observer standing outside of space and time, looking at the entire bubble of existence, forcing it to be real? Or is the universe a giant superposition, a magnificent, shimmering ghost that has never truly decided what it is? Some ancient traditions speak of the world as Maya, or illusion. They say that the separation between the seer and the seen is false. Quantum mechanics seems to be whispering the same thing. The observer and the observed are an entangled system. You cannot stand apart from the world and measure it. You are woven into it. Your looking is the world. This erodes the barrier between subjective and objective. We tend to think of our feelings, our thoughts, our dreams as less real than the atoms and rocks outside. But if atoms and rocks are just probability clouds until a mind interacts with them, then perhaps the mind is the primary stuff of the universe. Perhaps consciousness is not a lucky accident of evolution. Perhaps it is the fundamental operating system of reality. Without the witness, there is no event. Without the story, there is no history. This is a heavy responsibility. It means you are not just a passenger on Earth. You are a pillar. Your awareness is holding your corner of the universe up. If you were to cease perceiving, a part of the richness of the cosmos would vanish forever. The specific color of the sky today, the specific sound of the wind in the trees, the specific feeling of the chair against your back. These exist only in the interaction between the quantum soup and your specific, unique consciousness. You are the only Wigner for your own life. No one else can open the door to your inner laboratory. No one else can collapse your wave function. You are the sole custodian of your own reality. This can feel lonely. It creates a sense of isolation, a fear that we can never truly reach another person, that we are always shouting across a quantum divide. But there is a flip side. If reality requires an observer, then the universe needs you. It needs eyes to see itself. It needs minds to wonder about itself. It produced you, not just to live in it, but to define it. You are the universe's way of making itself real. So, as you sit here, look around the room again. Realize that you're doing work. Just by seeing the walls, you're painting them. Just by feeling the air, you are sculpting it. You are a reality generator, a quantum artist. The silence around you is waiting for your attention to give it form. But if every observation creates a reality, and if every choice splits the world, then what happens to the roads not taken? What happens to the version of you who made a different choice? The version who didn't read this script? The version who turned left instead of right? The version who didn't survive that accident years ago? Our seventh brutal fact takes the idea of subjective reality and shatters it into infinite shards. We are going to explore the multiverse. We are going to face the possibility that death itself might be an illusion. And we are going to ask the question, are you the only you? Or is the cosmos crowded with an infinite number of your ghosts, living out every life you never had? Prepare yourself for the fracture. The single timeline is about to break. Regret is a shadow that follows us all. We look back at our lives, and we see a landscape of crossroads, the moments where we turned left instead of right, the job we didn't take, the person we didn't kiss, the words we didn't say. We are haunted by the what-ifs. We imagine the versions of ourselves who made different choices, living better, happier, fuller lives in some imaginary parallel world. We comfort ourselves by saying that those worlds are just fantasies. They are dreams. They are not real. There is only one you. There is only one reality. And you are living in it, for better or for worse. But the seventh brutal fact of quantum mechanics tears this comfort away. It suggests that your regrets are not fantasies. They are window shopping. It suggests that those other versions of you are not imaginary. They are just as real, just as flesh and blood, just as conscious as the version reading these words right now. Welcome to the many worlds interpretation. To understand this, we have to look at the math of quantum mechanics without flinching. Remember the Schrödinger equation? The beautiful formula that describes how particles behave as waves? It is perfect. It is linear. It is deterministic. It tells us that A particle will evolve into a superposition of all possible states. It does not say anything about collapse. It does not say anything about the wave suddenly snapping into a single point. The idea of collapse was added by physicists like Niels Bohr because that is what we see. We see one outcome, so we invented a rule to get rid of the others. But in 1957, a brilliant graduate student named Hugh Everett III asked a dangerous question. What if we believed the math? What if the wave function never collapses? What if the universe doesn't choose? What if it does everything? According to Everett, when you measure a quantum particle that is in a superposition of up and down, the universe doesn't pick one. Instead, it splits. It cleaves in two. In one branch of reality, the particle is up, and there is a version of you who sees it as up. In the other branch of reality, the particle is down, and there is a version of you who sees it as down. These two branches are now separate. They cannot communicate. They cannot see each other. But they both exist. And this doesn't just happen in laboratories. It happens every time a quantum interaction occurs. And since your brain is made of atoms, and atoms are quantum systems, it happens every time you make a decision, every time a neuron fires or doesn't fire, every time a chemical bond forms or breaks. The universe is constantly shattering into a kaleidoscope of infinite possibilities. Think about what this means for you. It means that every time you faced a brush with death, you died, and you survived. Imagine a car accident. You are driving down a wet road. A truck swerves. In a billion branches of reality, your reflexes are slightly too slow. The neurons don't fire in time. You crash. You die. Your family grieves. Your story ends. But in a billion other branches, a random quantum fluctuation in your brain causes a neuron to fire a millisecond faster. You turn the wheel. You miss the truck by an inch. Your heart pounds. You drive home, shaken but alive, telling yourself how lucky you were. According to the many worlds interpretation, both of these things happened. The tragedy and the miracle. They are both real history. But here is where the horror sets in. It is a concept known as quantum immortality. Imagine you are the driver. You can only experience the timeline where you are conscious. You cannot experience the branch where you died. From your perspective, the screen goes black. The timeline ends. There is no you there to observe it. So, your consciousness will always, inevitably, find itself in the branch where you survived. No matter how unlikely the survival was, no matter how slim the odds, if there is even one path in a trillion where the gun jams, where the rope breaks, where the cancer spontaneously goes into remission, you will experience that path, because it is the only path to experience. You are trapped in life. You are condemned to survive. From your own first-person perspective, you might never be able to die. You will watch everyone around you pass away. You will see your friends and family succumb to the probabilities of illness and accident in your branch. But you will keep going. You will become the statistical anomaly, the person who miraculously survives the crash, the person who lives to be 100, then 110, then 120. Your body might fail. You might be in pain. You might be crumbling. But as long as there is a sliver of consciousness left, a tiny quantum thread of awareness, you will be anchored to it. You will be the oldest person on earth, wondering why death refuses to take you. This is the curse of infinity. It is the terrifying opposite of the fear of death. It is the fear of no death. It creates a sense of profound vertigo. It makes you wonder, how many times have you died already? How many timelines have you left behind, filled with grieving funerals, while you simply blinked and carried on, unaware of the bullet you just dodged? Did you almost die in your sleep last night? Did a blood clot pass through your heart and dissolve just in time? In another world, you didn't wake up this morning. But here you are, the survivor, the chosen one. Not because you are special, but because being here is the only thing you can do, and it extends beyond survival. It extends to identity. We cherish the idea of our unique soul. I am me. I am the sum of my memories and choices. But in the multiverse, you is not a single person. You is a colony. You are a vast branching coral reef of consciousness. There are versions of you who are murderers. There are versions of you who are saints. There are versions of you who are billionaires, and versions who are destitute. There are versions of you who married that person you lost, and versions who never met them. Every potentiality of your soul is being acted out somewhere in the great library of the multiverse. This dilutes the weight of your choices. If you choose to be kind today, that is beautiful. But another version of you chose to be cruel. Does your kindness matter if the cruelty exists anyway? Does your moral struggle have meaning if every outcome is guaranteed to happen? It can feel like nihilism. It can feel like nothing matters because everything happens. But there is another way to look at it, a gentler way. If there are infinite versions of you, then you are never truly alone. You are surrounded by a ghostly chorus of yourself. And in the grand tapestry of the multiverse, every mistake you have ever made has been corrected by another you. Every regret you carry is a victory for another you. The road not taken was taken. The life unlived was lived. You do not have to carry the burden of all possibilities on your one set of shoulders. You are just exploring one specific path through the garden. You are the scout for the collective. Your job is not to be perfect. Your job is simply to witness this timeline, to see what happens down this particular road, to feel the specific texture of this joy and this sorrow. The other yous have their own burdens. They have their own regrets. Perhaps they regret not making the choice you made. Perhaps the you who became a billionaire is lonely and looks across the quantum void, wishing they had chosen the simpler life you are living right now. The grass is always greener in the other quantum branch. But you're here, and here is the only place that matters to you. The multiverse is vast, yes. It is terrifying, yes. It strips us of our uniqueness, but it also connects us to everything. It means that somewhere, in some branch of reality, everything is okay. Somewhere, the lost are found. Somewhere, the broken are healed. Somewhere, the story has a happy ending. And because you are part of the great quantum whole, that happy ending belongs to you too, in a way. It is happening to a part of your soul that you cannot see, but that is nevertheless real. So, when you feel the pang of regret, when you wonder, what if? Close your eyes and send a silent thought to your other selves. Wish them well. Trust that they are handling the other paths. And then open your eyes and commit to this one. This is your assignment. This slice of the multiverse is yours to observe, yours to create, yours to collapse. Make it a good one. But as we stand here, contemplating the infinite branches of reality, a final question arises, a question that threatens to undermine not just our lives, but the very structure of the logic we are using. We have talked about atoms. We have talked about waves. We have talked about the multiverse. We have assumed that we are rational beings, evolving in a rational universe, capable of understanding the truth. But what if that assumption is wrong? What if our brains are not reliable observers? What if we are not the complex biological creatures we think we are? What if we are something much simpler and much more horrifying? Our eighth and final brutal fact is the monster at the end of the book. It is the theory that suggests you might be the only thing that exists, and not even you as you know yourself, but just a fleeting spark of madness in the void. Prepare for the ultimate dissolution. We are going to meet the Boltzmann brain, and we are going to find out if you are really reading this, or if you're just hallucinating the entire universe in a flash of random static. The journey is almost over, or maybe it never really began. We tell ourselves a story about how we got here. It is a grand, epic story. It begins with a bang, a primordial explosion that gave birth to time and space. It continues through the swirling coalescence of gas clouds, the ignition of the first stars, the forging of heavy elements in nuclear fires. It moves to the formation of rock and water, the spark of life in a warm chemical soup, the slow, agonizing climb of evolution from single cells to complex creatures. It includes the dinosaurs, the ice ages, the rise of civilizations, the invention of language, the building of cities, and finally, your parents meeting, and you being born. It is a story of cause and effect, stretching back 14 billion years. It gives us context. It gives us roots. It tells us that we are the result of a long, arduous process of cosmic selecting and refining. But our eighth and final brutal fact suggests that this story might be a lie. It suggests that the past did not happen. It suggests that the stars you see are not real. It suggests that you are not a biological organism with a history, but a momentary flicker of order in a universe of chaos. Welcome to the concept of the Boltzmann brain. To understand this nightmare, we must understand entropy. Entropy is the measure of disorder. The second law of thermodynamics tells us that in a closed system, entropy always increases. Things fall apart. Coffee cools down. Buildings crumble. Universes expand and cool. Order is rare. Chaos is common. A highly ordered state, like a human brain containing memories of a complex past, is incredibly unlikely. It requires a tremendous amount of energy and organization to create. Now, let us look at the deep future of the universe. As we learned in previous chapters, the universe is expanding. Eventually, all the stars will burn out. All the black holes will evaporate. The universe will reach a state of heat death, or thermal equilibrium. It will be a vast, cold, dark soup of particles moving randomly in the void. This state of high entropy will last forever, not just for billions of years, but for eternity. But in a quantum universe, random does not mean still. Remember the vacuum fluctuations. Remember the particles popping in and out of existence. Given infinite time, even the most unlikely events will happen. If you have a box of random letters and you shake it for 1,000 years, you might get a few words. If you shake it for 1 billion years, you might get a sentence. If you shake it for eternity, eventually, purely by chance, the letters will fall into the exact arrangement of the complete works of William Shakespeare. It is statistically inevitable. Now, apply this to the atoms in the void. In the eternal darkness of the heat death, particles are bumping into each other randomly. Most of the time, they form nothing, but occasionally, they might form a hydrogen atom. Rarely, they might form a molecule. And over spans of time so vast that they make the current age of the universe look like a single tick of a clock. A random fluctuation will arrange particles into something complex, like a brain, a fully formed conscious brain, complete with neurons, synapses, and electrical signals. And not just a blank brain, but a brain encoded with memories. Memories of a childhood that never happened. Memories of a family that never existed. Memories of reading a script about quantum mechanics on a screen that isn't there. This is a Boltzmann brain, named after the physicist Ludwig Boltzmann, who first pondered the relationship between entropy and probability. Here is the terrifying part. The probability of a single brain fluctuating out of the void is incredibly small. It is infinitesimally tiny, but the probability of an entire universe evolving with billions of galaxies, stars, and planets is even smaller. It takes much more order, much more luck, to make a Big Bang and a whole cosmos than it does to make just 1 kilogram of gray matter. So, if we are playing the odds, if we are betting on what is most likely, it is overwhelmingly more probable that you are a Boltzmann brain floating in the void than a human being living in a real universe. The math is brutal. In an infinite timeline, there will be vastly more freak observer brains than biological ancestor brains. The ratio is not even close. It is billions upon trillions to 1. This leads to the paranoid conclusion: why do you think you are the exception? Why do you assume you are one of the rare real humans? The logic of probability says you are almost certainly a hallucination. The room around you, it is just a random firing of neurons. The sensation of the chair, a chance arrangement of electrical impulses. The history you remember, fake data written onto your hard drive by a cosmic accident. And the worst part? Because this brain is a random fluctuation, it is unstable. It does not have a life support system. It does not have a body. It appears. It thinks, I am reading about quantum mechanics. And then it dissolves. The particles drift apart. The fluctuation ends. The experience of reading this sentence might be the only moment of existence you ever have. The moment before this did not exist. The moment after this will not exist. You are a flash in the pan of eternity, a solitary spark in the endless night. This idea is so disturbing that physicists hate it. They call it the Boltzmann brain paradox. They use it as a reductio ad absurdum, a way to test theories. They say, if a theory of the universe predicts that Boltzmann brains are more common than real observers, then the theory must be wrong. Because if we are Boltzmann brains, then science itself is meaningless. We cannot trust our observations. We cannot trust our memories. We cannot learn anything about the universe because the universe we see is just a dream. So, scientists strive to find models of cosmology where the universe decays faster than these brains can form, or where the nature of the vacuum prevents them. They are fighting for the reality of reality. They are fighting to prove that we are not just ghosts in the machine. But the fear lingers. It lingers because it touches on the ultimate solitude. Solipsism again, but stripped of the ego. Not, I am the only thing that exists, but I am a mistake that exists for no reason. It strips our life of narrative. We love stories. We love beginnings, middles, and ends. We love growth. But the Boltzmann brain has no story. It has only a snapshot. It is a frozen frame of a movie that never was filmed. It forces us to ask, what is the value of a moment if it has no context? If you feel love for someone, but that person is a hallucination and the memory of them is false, is the feeling of love still real? If you feel awe at the stars, but the stars are just random static in your visual cortex, is the awe still valid? This is the final, brutal confrontation with the self. It forces us to retreat into the only thing we can be absolutely sure of. Descartes said, I think, therefore I am. Even if I am a Boltzmann brain, I am thinking. Even if I am a fluctuation, I am experiencing. The content of the experience might be a lie, but the fact of the experience is truth. There is an I, There is a here. There is a now. Maybe that is enough. Maybe we don't need 14 billion years of history to justify our existence. Maybe the miracle is simply that in the infinite, dead, cold dust of the universe, something woke up, even for a second, even by accident. Something said hello. Something felt warmth. Something wondered. And perhaps, in the grand, cold calculus of entropy, that single flash of consciousness is the victory. It is the universe cheating death. It is chaos accidentally creating meaning. So, look at your hand one last time. Is it made of atoms forged in stars? Or is it a phantom limb generated by a lonely mind in the void? You will never know for sure. You cannot step outside of your own mind to check. You are trapped in the box of your own perception. But as you sit here, breathing, feeling, thinking, does it matter? The experience is vivid. The emotion is rich. The mystery is profound. Real or not, you are here. You are the witness. You are the eyes of the void. And this brings us to the end of our 8 facts. We have journeyed from the empty atom to the entangled cosmos, from the boiling vacuum to the looping timeline, from the observer's trap to the fractured multiverse, and finally to the possibility that it is all a dream. We have stripped away the solid ground beneath your feet. We have taken away your certainty. We have left you floating in a strange, shimmering, ghostly ocean of probability. And yet, you are still you. You have not dissolved. You have not vanished. You have survived the journey. And perhaps you are different now. Perhaps the world looks a little less rigid, a little more magical, a little more fluid. We have deconstructed reality. Now, in the coming chapters, we must try to put it back together. We must find a way to live with these truths. We must find a way to integrate this cosmic vertigo into our daily lives without losing our minds. We must find the bridge between the quantum nightmare and the human dream. Because if we are ghosts capable of love. If we are accidents capable of beauty. And if we are hallucinations, let us make it a beautiful hallucination. The science stops here. The contemplation begins. We have stared into the abyss, and the abyss has stared back. Now, we must decide what to say to it. We must decide how to be human in a universe that seems designed to deny our humanity. So take a deep breath. Let the air fill your lungs, real or imagined. Feel the beat of your heart, biological or statistical, and prepare for the synthesis. Prepare to find the peace that hides inside the panic. The journey is not over. We have only just reached the bottom of the rabbit hole. Now, we must build a home there. We have spent the last 8 chapters exploring the darkness. We have looked at the hollowness of atoms, the madness of superposition, the ghosts of the multiverse, and the hallucinations of the void. We have painted a picture of a universe that seems alien, hostile, and utterly indifferent to the rules of logic that govern our lives. It is easy to feel a sense of dread after such a journey. It is easy to feel that the quantum world is a defect, a glitch, a realm of chaos that lurks beneath the surface of our orderly world, like a monster's under the bed. We want the world to be solid. We want it to be predictable. We want atoms to be marbles and time to be a straight line. But the 9th step of our journey brings a twist that changes everything. It is the realization that the monster is not trying to destroy us. In fact, the monster is the only reason we are alive. If the universe were normal, if it followed the sensible, solid, classical rules that we think we want, we would not be here to complain about it. The stars would be dark, the chemistry of life would be impossible, and the universe would be a cold, dead graveyard of inert matter. Welcome to the realization that quantum mechanics is not just a curiosity, it is the fuel of existence. Let us look at the sun. Every morning it rises in the east, bathing our planet in warmth and light. It drives the weather, feeds the plants, and powers the entire chain of life on Earth. We know, thanks to modern science, that the sun is a nuclear furnace. It fuses hydrogen atoms into helium, releasing energy in the process. This seems straightforward, but here is the brutal fact that classical physics cannot explain. The sun is too cold to shine. At its core, the sun is about 15 million degrees Celsius. That sounds incredibly hot. But in the world of nuclear physics, it is tepid. It is nowhere near hot enough to force two protons to fuse together. Protons are positively charged. They hate each other. They repel each other with a ferocious electromagnetic force. To overcome this repulsion and get them close enough to stick together, you need to smash them into each other at incredible speeds. According to classical calculations, the protons in the sun are moving too slowly. They should bounce off each other like billiard balls. They should never get close enough to fuse. If the laws of classical physics were the only laws, the sun would not ignite. It would be a glowing ball of gas, perhaps, but it would not be a star. It would fade out. The earth would freeze. Life would never begin. So, why does the sun shine? It shines because of the very weirdness we found so disturbing in Chapter 2. It shines because of quantum tunneling. Remember how the electron is not a particle but a wave? Remember how it doesn't have a single location, but a probability distribution? When two protons in the sun rush toward each other, they hit that electromagnetic wall of repulsion. Classically, they should stop and turn back. But because they are quantum waves, their location is fuzzy. The leading edge of the wave hits the wall, but the tail of the wave extends through the wall. There is a tiny, tiny probability that the proton can simply appear on the other side. It doesn't climb over the wall. It doesn't break through the wall. It simply ceases to be on one side and instantly exists on the other. It teleports. It cheats. This tunneling event is incredibly rare. For any individual proton, the chance of it happening is 1 in a trillion trillion. But because the sun contains so many protons, and because they are colliding so often, this rare event happens enough times every second to power the star. Every ray of sunlight that hits your face is a result of a particle breaking the rules of classical logic. Every calorie of energy you eat began its journey as a quantum ghost walking through a wall. The warmth you feel is the heat of quantum uncertainty. Suddenly, the fuzziness of the world doesn't seem so scary. It seems miraculous. It is the loophole that allows the universe to turn the lights on. But the miracle doesn't stop at the stars. It continues right here, in the very structure of your body. Recall Chapter 1, where we learned that atoms are 99% empty space. We asked why we don't fall through the floor. We answered electromagnetic repulsion. But there is a deeper answer, a quantum rule that gives the universe its variety and its structure. It is called the Pauli exclusion principle. This rule states that no two electrons can occupy the exact same quantum state in the same place at the same time. They are antisocial. They refuse to stack on top of each other. If electrons didn't have this rule, if they were allowed to all crowd into the lowest energy level, every atom would collapse. The electrons would all fall into the bottom shell, hugging the nucleus tightly. Chemistry, as we know it, would vanish. There would be no chemical bonds. There would be no complex molecules. There would be no carbon chains, no DNA, no proteins. All matter would be a bland, uniform soup of super-dense blobs. But because electrons are stubborn, because they demand their own space, they stack up They form shells. They create the complex, beautiful geometries of the periodic table. Carbon behaves differently than oxygen because its electrons are forced into different arrangements by this quantum rule. The vast complexity of biology, the fact that you can have eyes to see and a brain to think, is due entirely to this quantum refusal of particles to merge. So, the emptiness of the atom is actually filled with an invisible architecture of quantum laws. It is a scaffolding made of rules. This changes our perspective on the chaos of the quantum realm. It is not chaos. It is a different kind of order. It is a flexible, dynamic, shimmering order that allows for possibilities that a rigid, classical universe could never support. A classical universe would be a clockwork mechanism, predictable, stable, dead. A quantum universe is a jazz improvisation, unpredictable, risky, alive. It allows for the unexpected. It allows for the sun to burn when it shouldn't. It allows for mutations that drive evolution. It allows for the emergence of consciousness from wet chemistry. This brings us to a profound shift in how we view ourselves. We are not victims of the quantum absurdity. We are the children of it. We are the direct product of the universe's ability to be in two places at once, to borrow energy from the void, and to tunnel through barriers. Our very existence is a testament to the creative power of the weird. Think about photosynthesis, the process by which plants turn sunlight into life. For decades, biologists thought this was a messy, classical chemical reaction. But recent studies suggest that plants use quantum coherence, superposition, to transport energy with near-perfect efficiency. The energy from a photon doesn't bounce around the cell randomly looking for the reaction center. It spreads out like a wave. It tries all paths at once. It finds the most efficient route instantly. The plants are using quantum computing, the birds navigating by the magnetic field of the earth. They are using quantum entanglement in their eyes to see the magnetic lines. The enzymes in your body that digest your food, they use quantum tunneling to move protons around and speed up reactions. You are a quantum machine. You are walking, talking, thinking proof that the quantum world is not down there in the microscopic dark. It is up here. It is woven into the fabric of life itself. This realization bridges the gap between the cold, alien math and the warm, human experience. We are not separate from the mystery. We are the mystery in motion. The brutal facts we listed, the emptiness, the lack of location, the retrocausality, these are not defects. They are features. They are the superpowers of matter. And they are your superpowers, because you are made of this stuff. You are not made of solid, dumb bricks. You are made of vibrating fields of infinite potential. You are made of stardust that learned to tunnel. You are made of light that learned to be solid. This invites a new kind of humility and a new kind of pride. Humility because we realize how fragile our existence is, dependent on a delicate balance of improbable forces. Pride because we realize how rare and magnificent it is to be a stable structure in a boiling ocean of probability. We are the universe's way of singing. We are the music made by the strings of theory, and the song is beautiful. So, as we prepare for the final chapter of our journey, let the fear dissolve. Let the existential dread of the Boltzmann brain and the false vacuum fade away. Replace it with wonder. Replace it with the realization that you are an impossible object in an impossible world. You have walked through the valley of the shadow of quantum mechanics. You have seen the ghosts, and you have realized that the ghosts are friendly. They are holding you together. They are keeping you warm. They are reading these words through your eyes. The universe is not silent. It is humming, and you are the hum. Now, we have one final step to take. We must answer the question, so what? What do we do with this knowledge? How do we live our lives differently, knowing that we are entangled, empty, and infinite? How do we take this cosmic perspective and bring it down to the breakfast table? The final chapter is an invitation. It is a call to action. It is a request for you to stop being a passive observer and start being an active participant in the great quantum experiment of existence. The science is done. The philosophy is done. Now, only the journey remains, and the journey is yours. We have arrived at the end of our descent. We have traveled from the hollow silence of the atom to the shimmering madness of the multiverse. We have confronted the possibility that time is a loop, that reality is a hallucination, and that we are merely fleeting sparks in a cold, indifferent void. But we have also discovered something else, something that shines brighter than the fear. We have discovered that we are woven into the very fabric of this mystery. We are not outsiders looking in. We are not spectators watching a cosmic play from the safety of the dark. We are the play. We are the actors, the scriptwriters, and the audience, all entangled in a single, breathtaking moment of existence. The 10th and final truth is not a brutal fact of physics. It is a gentle realization of the heart. It is the understanding that the weirdness of the quantum world is actually an invitation. It is the universe inviting you to wake up. Think back to where we started, the illusion of solidity, the realization that you are mostly empty space. At first, this felt like a loss. It felt like you were fading away, becoming a ghost. But look at it again. If you're empty space, then you're open. You're not a closed fortress. You are a vessel. You are permeable to the forces of the cosmos. The neutrinos from the sun are streaming through you right now, passing through the vast gaps in your atoms like wind through a forest. The gravity of distant galaxies is pulling gently on every cell in your body. The electromagnetic fields of the earth are guiding the chemistry of your blood. Your emptiness is what allows you to be connected to everything else. If you were truly solid, truly dense, you would be isolated. But because you are spacious, the universe can flow through you. You are breathing the cosmos in and out with every moment. And what about the nightmare of location? The idea that you are a wave smeared out across space, only collapsing when observed? This, too, is a liberation. It means you are not fixed. You are not static. You are a field of potential. You are a cloud of possibilities waiting to happen. We often feel stuck in our lives. We feel trapped by our circumstances, by our past, by our definitions of who we are. I am this kind of person. I have this kind of limit. But quantum mechanics whispers that this rigidity is an illusion. Deep down, in the basement of your being, you are fluid. You are capable of sudden, discontinuous change. You are capable of tunneling through the walls that seem to block your path. You are capable of shifting your state in an instant. The physics that allows the sun to shine is the same physics that allows you to grow. You are built on a foundation of transformation. And then there is the entanglement, the spooky action at a distance, the death of separation. This is the antidote to the great human ache of loneliness. We walk through this world feeling cut off. We feel like islands shouting across the sea. But the physics tells us that the sea is an illusion. Beneath the water, the land is one. The particles that make up your body have been dancing with the particles of the universe for 14 billion years. You have never been alone, not for a single nanosecond. The silence you feel in an empty room is not the silence of absence. It is the silence of presence. It is the quiet hum of the invisible threads that bind you to the Orion Nebula, to the center of the Milky Way, to the first light of the Big Bang. When you feel love, when you feel empathy, when you feel that strange resonance with another human being or a piece of music or a starry sky, maybe you are feeling the tug of that ancient entanglement. Maybe you are feeling the reality of the connection that physics has finally proven to be true. You are a node in a cosmic network. You are a receiver and a transmitter of the universal song. And what of the observer? The power of the mind to collapse the wave. This is the ultimate empowerment. It tells us that we matter. For centuries, science seemed to be telling us the opposite. Copernicus moved us out of the center of the solar system. Darwin moved us out of the center of creation. Hubble moved us into a tiny corner of a vast, expanding universe. We felt smaller and smaller, insignificant, accidental. But quantum mechanics has brought us back to the center, not the geometric center, but the causal center. It says that the universe is not complete without us. It says that the story requires a listener to be real. You are the keeper of the collapse. You are the one who decides, moment by moment, which reality becomes actual. This is a heavy responsibility, yes, but it is also a beautiful dignity. It means that your attention is a creative force. Where you look, reality hardens. What you focus on grows. If you focus on fear, on separation, on chaos, you collapse those wave functions. You bring that version of the multiverse into being. But if you focus on connection, on wonder, on beauty, you bring that reality to life. You are constantly gardening the quantum field. You are constantly choosing which seeds of probability will germinate into the flowers of history. So, the question, so what, has an answer. The answer is, live like you matter, because you do. Live like you are connected, because you are. Live like the world is a mystery, waiting for your eyes to give it form, because it is. We started this journey with the idea of brutal facts, facts that scare scientists. But as we stand here at the end, the brutality has softened into awe. The fear was just the ego trying to hold on to a control it never had. Once we let go, once we accept that we are swimming in a sea of uncertainty, the water holds us up. The mystery becomes a home. There is a peace in not knowing. There is a peace in realizing that the universe is smarter, stranger, and more magnificent than our small logic can comprehend. It invites us to stop trying to conquer it and start trying to dance with it. It invites us to replace our demand for answers with a capacity for wonder. So, here is your invitation. Tonight, when you turn off the screen, when you lay your head on the pillow, do not just go to sleep. Enter the void consciously. Feel the emptiness of the room as a fullness of energy. Feel the silence as a conversation. Feel your body not as a heavy object, but as a shimmering cloud of energy fields, hovering, vibrating, glowing with the light of ancient stars. Close your eyes and visualize the wave function of your life spreading out. See the infinite versions of yourself in the multiverse and send them love. Acknowledge the deep past and the deep future meeting in the center of your chest. And then let go. Drift into the quantum soup of dreams. Trust that the universe will hold you together. Trust that when you wake up, the observer will return and the world will be waiting for you to create it again. This journey we have taken is just a beginning. The rabbit hole goes deeper. There are always more questions, always more layers, always more mysteries. That is the joy of it. If we knew everything, the game would be over. But the game is infinite. We are eternal students in a library that has no walls, and we are exploring it together. This voice you are hearing, these words you are reading, they are just one wave interfering with yours. We are entangled now. We have shared this journey, and that connection is now part of the history of the universe. It is a permanent knot in the fabric of time. If you have found value in this exploration, if you have felt a shiver of awe, a moment of vertigo, or a spark of peace, then you are part of our community of explorers. You are one of the curious ones, one of the observers who likes to look at the dark and see the light. We want you to stay with us. We want you to continue this journey. There are more stories to tell, more paradoxes to unravel, more brutal facts to transform into beautiful truths. So, if you are ready for the next chapter, if you are ready to go even deeper, please take a moment to join us. Like this video to collapse the wave function of our connection. Subscribe to the channel to entangle your future with ours. Leave a comment below and tell us which fact scared you the most and which one set you free. Your thoughts are the measurements that make this channel real. Without you, we are just a probability. With you, we are a reality. Thank you for watching. Thank you for thinking. Thank you for existing. You are the universe observing itself. And the universe is beautiful. Until next time, keep looking up, keep asking questions, and never be afraid of the dark, because the dark is where the magic happens. Good night, and welcome to the mystery.